In Lesson 3.2, Multiplication Facts, we're going to review strategies for solving multiplication facts, and you'll also be introduced to some new terminology, factors, multiples, square numbers, prime numbers, and composite numbers. So even though this lesson may seem easy, you still want to focus on some of this new vocabulary. So you may see a multiplication chart here that's not completely filled in. What I want you to do is just focus on the blue shaded regions at the top and along the left-hand column. What you will notice here is that these are factors, numbers that are multiplied together to give you a product or what you might call an answer. So for example, if I take the number 24, 1 times 24, those are factors. 2 times 12 multiplied together give you 24. 3 times 8 gives you 24. And 4 times 6. Those would be called factor pairs, meaning that they're written together as a pair of numbers. You also can write them in a long line. You may have done this in 3rd grade and referred to it as a rainbow. So 1 times 24, 2 times 12, 3 times 8, and 4 times 6. Here is where you get the rainbow effect. 3 times 8 and 4 times 6. Let me try another one. If I take the number 30, I'm going to write out all the factors of 30. I know that 1 times 30 equals 30. I know it's an even number, so I know that 2 times something must be 30. Anything that ends in even number, 2 is a factor. So 2 times 15, 3 times 10, and 5 times 6. Those are all the factors. I wrote those as factor pairs, but I also could write them out this way as well. 1 times 30, 2 times 15, 3 times 10, and 5 times 6. Again, these are numbers multiplied together to give you a product. Now, since I brought up the word product, let me write that down. Product is the answer to any multiplication problem. So if you look at this picture here, they show you 24 is a product of 4 times 6. So a product is the answer to a multiplication problem. The next thing that we're going to talk about is multiples. And multiples, if you look at this multiplication chart, they are when you take a number and multiply it by 1, by 2, by 3, by 4, by 5. So if I take this pointer, if I look at the multiples of 3, we start with 3 times 1. This whole row are all multiples of 3. The 6's, all along the 6's, those are multiples of 6. So if I were to write out the multiples of 6, what I would say is, what is 1 times 6? 6. What is 6 times 2? 12. What is 6 times 3? 18. What is 6 times 4? 24. What is 6 times 5? 30. And I could continue to go on and on. Those are all multiples of 6. Let's take another number. Let's take the number 9. So if I were to write out the multiples of 9, I always take 9 times 1, or whatever number it is, times 1 first. That is the first multiple. 9, 18, 27, 36. And if you notice, I'm going right along the 9s. So those are multiples. Now what we're going to do is look at those and put those into a Venn diagram and see which one of those numbers they have in common. So I'm going to go ahead and draw 2 circles that overlap. What I want to do is write the multiples of 6 and the multiples of 9. So if I would think about what I just did in the previous slide, I would write all my multiples of 6 in here. So 6, 12, 18, 24, 30, 36. Now I'm going to write the multiples of 9 in the other circle. 9, 18, 27, 9 times 4 is 36. 9 times 5 is 45. And I'm going to stop there. I'm going to look in those circles and see if there's anything that has both numbers in each of the circles. So I look at 18. That is a common multiple, as well as 36. So those numbers I would want to put in the center, meaning that they share a multiple. And then I could go ahead and erase the 18 from here, the 36, and do the same thing for the multiples of 9. Now in the next slide, I'm going to take two numbers, and I want you to set it up the same way on your whiteboard. So if you do not have a whiteboard yet, go ahead and pause the video, get a whiteboard, marker, and eraser, because you will be creating a Venn diagram for two different multiples. So on your whiteboard, draw two large circles, put a 3 above the left-hand one and a 4 above the right-hand one. And what you're going to do is take a few minutes and write in the first 5 multiples of each number. Remember, the first multiple is always 3 times 1 or 4 times 1. Go ahead and write in this area here and in this area here the first 5 multiples of each of those numbers. Go ahead and pause the video and write that on your whiteboard. So if I go ahead and we'll write in the multiples, I would write in 3, 6, 9, 12, 15, 4, 8, 12, 16, 20. So what you need to do then is find out what number or numbers are in both circles. And in this case, it would be 12. So then I would take and write 12 in the center and erase that from both of the lists. Square numbers are something unique. If you look at this multiplication table, you'll notice that there are numbers along a diagonal that are highlighted in yellow. Those are called square numbers. A square number is a product of a counting number multiplied by itself. For example, 9 is a square number because you take 3 times 3. 25 is a square number because you take 5 times 5 to get 25. You'll notice all along this edge here, these numbers are all square numbers. Now that we've talked about multiples, factors, and square numbers, I want to introduce you to prime numbers and composite numbers. Prime numbers are when it only has 2 factors. Remember, factors are number multiplied together to give you a product or an answer, and the only 2 factors they have are 1 times itself. So for example, 7 is a prime number because the only 2 factors it has is 1 and itself, 7. 11 is prime. It only has 2 factors, 1 and itself, 1 times 11. Now, 1 is not a factor because it only has 1 factor, 1. So it has exactly 2 factors. 13 has exactly 2 factors, 1 and itself. If a number is not prime, it has to be composite. Composite means that it has more than 2 factors. So if I take the number 15, for example, 15 has 1 times 15 and 3 times 5. Therefore, that number is composite because it has more than 2 factors. The number 9 is a composite number, 1 times 9 and 3 times 3. So that has more than 2 factors. So today for practice, you're going to be going to Math Journal page 56 and looking at factor pairs and prime numbers. Remember, you can always refer back to the video if you have any questions, or at any time you can stop and rewind and listen again.